Lesson 12.5 is the binomial theorem. Before we discuss the binomial theorem, we need to talk about this notation n choose r. So you have the parentheses and then a number above another number. It's not a fraction. It means n chose an r at a time, or n choose r, which means how many different ways can you have n things and choose r of them. The way that we calculate n choose r is it's n factorial divided by r factorial times n minus r factorial, where remember n factorial means every integer from 1 up to n multiplied by each other. So 1 times 2 times 3, so on and so forth up to n. We'll be calculating these on our graphing or scientific calculators. So if you go to math and then go to probability, one of the options is NCR. Make sure you don't choose NPR. We want the NCR one. And then the first number is your n value. That's how many total things you have. And then the second value is your r value, how many you're choosing. So then go ahead and pause the video and evaluate these either using this notation or finding that on your graphing calculator. For the first one, we have 3 choose 1. So I have 3 factorial divided by 1 factorial times 3 minus 1, which is 2 factorial. So the top is 1 times 2 times 3. 1 factorial is just 1. 2 to factorial is 1 times 2. So the 1 times 2 cancel. We end up with 3 over 1, which is just 3. 4 choose 0. 0 factorial is 1. So I end up with 1 times 2 times 3 times 4 over 1 times 1 times 2 times 3 times 4. So that just cancels everything out and you get 1. 7 choose 6. 7 factorial divided by 6 factorial times 1 factorial, it ends up being 7. And then 5 choose 2. 5 factorial divided by 2 factorial times 3 factorial, you end up with 10. A couple of properties that we should know: anything choose 0 is always 1. Because if we have all of these things and we want to pick 0 of them, there's only one way to do it. Similarly, anything choose itself is also 1, because if we have all of these things and we want to choose all of them, there's also only one way to do it. Anything choose 1 or anything choose 1 less than itself is always n, whatever that value is, because if you're just picking 1 at a time, then you have n ways to do that. Same thing if you're not picking 1 at a time, you have n ways to do that. In fact, any n choose r is always equal to n choose n minus r, because picking r things is statistically the same as not picking r things. This is Pascal's triangle. It's a visual representation of this. So for example, if I have 0 choose 0, then I have one way to do that. If I have one thing, I could have 1 choose 0, which is 1, or I could have 1 choose 1, which is also 1. This level would be if I had 2 things. So 2 choose 0, 2 choose 1, 2 choose 2, and so on and so forth. If you look, any 2 numbers above another number always add up to it. So 1 plus 2 is 3, 4 plus 6 is 10. So this is just a visual representation of this information. So what the binomial theorem says is it's a formula for expanding binomials. So for example, if we have like x plus 2 squared, that would be pretty easy just to multiply out. Even x plus 2 to the third would be pretty easy to multiply out. But if I asked you to expand x plus 2 to the 10th power, that would be a lot of multiplication. So the binomial theorem is a shortcut that helps us to multiply out these things. So what the binomial theorem says is your first term, if you have an expansion of x plus a to the nth power, so the first term is going to be n choose 0, whatever the first term is raised to the nth power, and whatever the second term is, including its sign, raised to the 0 power. Then you're going to add on the next one, which your value we call our r value is going to increase by 1 every single time, while the power on the first term is going to decrease by 1, and the power on the second term is going to increase by 1. And you keep doing that, so on and so forth, until you end up with n choose n, the power on the first term to be 0, and the power on the second term to be n. A couple patterns to recognize is that the first value, your n, is always your n, which is the power you're raising the original binomial to, which is also what the first term always starts raised to, and what the last term will always end raised to. And then whatever your r value, your n choose r, is always the same as the power on the second term. So 0, 0, 1, 1, all the way up until the last term is going to be n and then n. And then your 2 powers always add up to whatever the original power n was. So n plus 0 is n minus 1 plus 1 is n, so those always add up to n. So if we want to look at this expansion x plus 2 to the 5th, the first thing I'm going to do is I'm going to write out the entire expansion. So I'm raising this to the 5th power, which means my n value is going to be 5. I always start at r equals 0. My first term is x, and my second term is positive 2. So then x starts to the 5th power, 2 starts to the 0 power. Then my r value and my power on 2 increases by 1 every single time until I get to the last term, which they're both 5. And then my power on x is going to decrease by 1 every single time until I get to 0. So now I'm going to evaluate each piece of these. So I'm going to do my 5 choose r, either using the properties of the ones that I know or by using my calculator, and then also multiply in my exponents and all of that. So 5 choose 0 is 1, 5 choose 1 is 5, 5 choose 2 is 10, 5 choose 3 is 10, 5 choose 4 is 5, and 5 choose 5 is 1. And then I just raised x to whatever power it asked for. Anything to the 0 power is 1. So same thing with 2, raised it to a power, so anything to the 0 power is 1, and then raised them all to the power. And now I'm going to multiply everything together and write out my full expansion. So when I multiply everything together, my full expansion ends up being x to the 5th plus 10x to the 4th plus 40x cubed plus 80x squared plus 80x plus 32. So again, n is whatever power I'm raising the original binomial to, and that stays true all the way through. Then my r value starts at 0, which is also the power on the second term, including the sign, and that increases by 1 every single time until I get to n. And then the power on the first term starts at n and decreases by 1 every single time until I get to 0. Here's another expansion, 2y minus 3 raised to the 4th power. So go ahead and pause the video and try this expansion. Keep in mind that 2y is one whole term and that this negative needs to be attached to the 3. So because I'm raising this to the 4th power, my n is going to be 4. So I started with 4 choose 0, and then my first term is 2y, so that started to the 4th power, and my second term is negative 3, so that started to the 0 power. And then I have 4 choose 1, 2y quantity cubed times negative 3 to the 1st, plus 4 choose 2, 2y quantity squared times negative 3 squared, plus 4 choose 3 times 2y to the 1st times negative 3 cubed, plus 4 choose 4, 2y to the 0, negative 3 to the 4th. So then multiplying all these out, anything choose 0 and anything choose itself is always 1. And then anything choose 1 or choose 1 less than it is itself. So I end up with 1, 2y quantity to the 4th is 16y to the 4th. That's one of the most common mistakes, is making sure this whole term gets raised to the 4th power. And then negative 3 to the 0 is just 1. And then 4 choose 1 is 4. 2y quantity cubed is 8y cubed. Then at negative 3 to the 1st is negative 3. 4 choose 2 is 6. 2y quantity squared is 4y squared. Negative 3 squared is 9. 4 choose 3 is 4, 2y to the 1st is 2y, negative 3 quantity cubed is negative 27, 4 choose 4 is 1, 2y to the 0 is 1, negative 3 to the 4th is 81. So then to multiply everything out, we end up with 16y to the 4th minus 96y cubed plus 216y squared minus 216y plus 81. So again, be very careful when you have terms that are not just x or y, for example. Make sure you raise that whole thing to a power. And then when you have negative signs, your term is going to alternate signs depending on positive or negative powers. Another type of question they'll ask is to find the coefficient of a specific term instead of finding the entire expansion. So for example, it says find the coefficient of the y to the 8th term of the expansion 3y plus 2 to the 10th power. So what I like to do is I like to set up what I know I'm going to have in my expansion. So I know I need to have the n choose r part. I know I need to have the first term, the 3y raised to a power. And I know I need to have the second term, 2 raised to a power. Since I want this y to the 8th term, that means that I'm going to have 3y has to be raised to the 8th power. I know that n has to be 10 because that's what power we're raising the whole binomial to. So if this is 8, then I know that these two powers have to add up to 10. So therefore, I know that this power has to be a 2. And then if this power has to be a 2, that's always the same as our r value. So it's going to be 10 choose 2. So using my calculator, 10 choose 2 is 45. I have to make sure I distribute the 8th power to the 3 and the y. So I get 6,561 y to the 8th, and then 2 squared is 4. So I multiplied everything together, and the coefficient of the y to the 8th term is 1,180,980. So this one wants the coefficient of the x cubed term for the expansion 2x plus 1 raised to the 12th power. So go ahead and pause the video and try that one. So my n value is 12, and then I want the 2x raised to the third power because I want x cubed, which means that the 1 has to be raised to the 9th power so that these add up to 12, and then if this is 9, then my r value is 9. So 12 choose 9 is 220, 2x quantity cubed is 8x cubed, 1 to the any power is 1, so you end up with 1,760x cubed. The last type of question they'll ask is for a specific term number in the expansion. So for example, they want the 6th term in the expansion of x plus 2 to the 9th power. So I set it up the same way. I know I'm going to have my n choose r part. I know I'm going to have x raised to a power and 2 raised to a power. I know that n is 9. So then if I want to think about the term number, my first term has r equals 0. My second term has r equals 1. So what I notice is that my r value is always 1 less than the term number. So if I want the 6th term, that means that r is going to be 5. So if r is going to be 5, the power on my second term 2 is going to be 5. And then because they have to add up to 9, the power on x is going to be 4. So if I plug it in the calculator, 9 choose 5 is 126, x to the 4th is just x to the 4th, and then 2 to the 5th is 32. Multiply everything together, I end up with 4,032 x to the 4th. So a key piece to remember is that your r value is always 1 less than whatever your term number is, because you start at term number 1 with r to be 0. So try this last one. Find the 4th term in the expansion 3x plus 2 raised to the 8th power. So because my n value is 8, I'm going to have 3x raised to a power, 2 raised to a power. I'm going to have the 4th term, which means my r value is going to be 3, which means the power on 2 is going to be 3. These have to add up to 8, so my power on 3x is going to be 5. And then plugging everything in my calculator, 8 choose 3 is 56. 3x to the 5th power is 243x to the 5th. 2 cubed is 8. Multiply everything together, you end up with 108,864x to the 5th. So binomial expansion, using this pattern to expand out these binomials raised to a power, being able to do the entire expansion, or also being able to find specific terms in the expansion.